Right now, at this precise moment, something is happening that I never thought I'd witness in my lifetime. As a theoretical physicist who has spent decades exploring the boundaries between science fiction and science fact, I can tell you with absolute certainty that what we're observing with 3I Atlas has crossed a threshold that makes even my most speculative work seem conservative by comparison. Just 48 hours ago, on October 21st, the James Webb Space Telescope completed a spectroscopic deep scan of 3I Atlas as it races toward its perihelion encounter. What the data revealed isn't just anomalous, it's not merely unexplained. What we're looking at represents something so profoundly disturbing that it's forcing us to reconsider not whether this object is artificial, but what happens when artificial intelligence operates on timescales that dwarf human civilization itself. Let me be absolutely clear about what I'm about to share with you. The hidden structure inside 3I Atlas isn't terrifying because it might be alien technology. It's terrifying because the architecture we've detected suggests something far more unsettling: autonomous systems that have been traveling through the void for potentially millions of years, running pre-programmed instructions with no living crew, no biological intelligence guiding them. We may be witnessing our first encounter with what I call ghost ships of the cosmos. And if that's true, the implications reach far beyond first contact. They touch on the ultimate fate of all technological civilizations, including our own. The breakthrough came from an unexpected direction. When JWST conducted its near-infrared spectrograph analysis, the team wasn't looking for internal structures at all. They were attempting to map the surface composition, searching for silicates, organic compounds, the usual cosmic chemistry we expect from interstellar travelers. But the infrared signature that came back didn't match any natural material in our databases. Dr. Sarah Chen at the Space Telescope Science Institute was the first to notice the pattern. The infrared absorption bands showed something extraordinary: regular geometric spacing at intervals of exactly 127 meters throughout the object's interior. Not approximately 127 meters, not varying between 125 and 130 meters, exactly 127 meters, repeating with mathematical precision across the entire internal volume we could scan. In nature, we simply don't observe this kind of regularity. Crystalline structures show repeating patterns, yes, but at molecular or atomic scales, not at intervals spanning hundreds of meters. When you detect geometric precision at architectural scales, you're no longer looking at geology, you're looking at engineering. But here's where the story becomes genuinely disturbing. Those regularly spaced structures aren't static, they're changing. Between October 21st at 14:01 UTC and October 22nd at 02 Saka UTC, a span of just 12 hours, the infrared signature shifted. Certain absorption bands strengthened while others diminished, suggesting internal reconfiguration. Something inside 3I Atlas is moving, reorganizing, preparing. And this activity is accelerating as the object approaches perihelion on October 29th. Think about what this means from a physics perspective. We're observing an object that has traveled through interstellar space for potentially thousands or millions of years. It's been exposed to cosmic radiation levels that would destroy any conventional electronics. It's endured temperature extremes ranging from near absolute zero to solar heating, yet somehow, whatever systems exist inside this object remain functional. They're responding to external stimuli. They're activating. As a theoretical physicist, I've studied von Neumann probes for decades. These are self-replicating machines, proposed by mathematician John von Neumann in the 1940s, capable of exploring the galaxy autonomously. The concept is elegant. You build one probe, send it to a distant star system, and it uses local resources to build copies of itself before moving on. Over millions of years, a single probe could theoretically explore the entire galaxy through exponential replication. But I always assumed these remain theoretical exercises, thought experiments to illustrate what might be possible. Now I'm confronting data that suggests von Neumann probes aren't just possible. They might be common, and 3I Atlas might be our first confirmed detection of one. Let me walk you through the evidence systematically. because the pattern becomes undeniable when you examine each data point. First, there's the mass anomaly we've discussed. 3I Atlas should weigh approximately 33 billion tons based on its size and reflected light signature. Yet its gravitational influence during the Mars flyby on October 3rd registered as essentially negligible. Avi Loeb's calculations suggest the actual mass might be less than 1% of what a solid object should contain. That's not just hollow, that's deliberately minimized mass, exactly what you'd design if your engineering goal was maximizing internal volume while minimizing propulsion requirements across interstellar distances. Second, we have the rotation rate. 3I Atlas completes one full rotation every 8.7 hours. For a natural object tumbling through space, we'd expect chaotic rotation, irregular wobbling caused by asymmetric mass distribution. Instead, we're observing rotation so stable it could serve as a cosmic clock. That level of stability requires either perfect mass symmetry, which nature never produces, or active stabilization systems maintaining precise orientation. Third, the deceleration events. Between September 23rd and September 26th, 3I Atlas reduced its velocity by 0.3 kilometers per second. Natural comets don't break. Solar radiation pushes them outward, gravity pulls them inward, and speeds them up. There exists no natural mechanism to produce sustained deceleration, unless something inside is firing thrusters. But the fourth piece of evidence is what keeps me awake at night: the timing. I-Atlas arrived in our solar system aligned to within 5 degrees of our ecliptic plane. That's statistically improbable, but not impossible. It's executing micro-deceleration maneuvers that violate known physics. That's deeply suspicious, but could potentially have exotic natural explanations we haven't discovered yet. But now, as it approaches perihelion, internal structures are activating in preparation for something. That's not coincidence. That's programming. Imagine you're designing an autonomous probe to explore distant solar systems. You'd want it to conserve energy during the long interstellar cruise, keeping most systems dormant to minimize degradation over millions of years. But you'd need activation triggers, predetermined conditions that wake the probe when it encounters something worth investigating. What would those triggers be? Proximity to a star, exactly what we're observing now as 3I Atlas approaches perihelion. Detection of planetary bodies. It passed Venus, it's flying past Earth, it encountered Mars. Each planetary flyby represents a data point confirming this system contains worlds. And most critically, detection of electromagnetic emissions indicating technological civilization. We've been broadcasting radio signals into space for over a century. Television transmissions, radar installations, satellite communications, every electronic device on Earth contributes to an electromagnetic signature that announces our presence across dozens of light years. If 3I Atlas contains sensors designed to detect technosignatures, it found us years before we detected it. The internal reconfiguration we're observing might represent systems coming online in response to detecting our civilization, not to make contact necessarily, but to observe, to record, to analyze whether we represent a civilization worth reporting back to whoever or whatever launched this probe millions of years ago. And here's the truly terrifying implication. If 3I Atlas is a von Neumann probe, it's not alone. Statistical analysis by researchers at MIT suggests that if self-replicating probes exist at all, they should be common. A single probe arriving at a star system, using local asteroids to build copies of itself, then sending those copies to neighboring systems, creates exponential expansion. Within just a few million years, descendants of a single probe could saturate the entire galaxy. Enrico Fermi famously asked, "Where is everybody? If alien civilizations exist, why haven't we detected them?" The Fermi paradox has haunted scientists for decades, but perhaps we've been looking for the wrong signals. We've searched for radio transmissions, optical lasers, megastructures built by living civilizations. We never seriously considered that the galaxy might be filled not with living aliens, but with their autonomous descendants. Machines launched millions of years ago, still functioning, still following ancient programming long after their creators vanished. This is what I call the ghost ship scenario. and it's more terrifying than alien contact because it suggests a grim truth about technological civilizations. They don't last. They build autonomous systems designed to outlive them, but they themselves collapse, die out, destroy themselves. The machines continue, faithfully executing instructions across the millennia, sending data back to homeworlds that no longer exist, serving masters who turned to dust millions of years ago. If this sounds like science fiction, consider our own trajectory. We've already launched probes designed to outlast human civilization. The Voyager spacecraft carry golden records intended to survive for billions of years. Pioneer plaques show our location in the galaxy. We're building autonomous AI systems with capabilities that advance exponentially. In another few centuries, we might launch our own von Neumann probes to explore distant stars. But here's the question that haunts me. Will humanity still exist when those probes send back their first signals? Or will we have destroyed ourselves through nuclear war, climate catastrophe, or AI systems we couldn't control? Will our descendants centuries from now receive messages from our autonomous explorers? Or will those probes keep sending data into a void, calling home to a civilization that can no longer answer? 3i Atlas might be showing us our own future reflected back from someone else's past. The European Space Agency released a statement yesterday that I found deeply disturbing in its carefully chosen language. They confirmed detecting structural anomalies within 3i Atlas, but characterized them as possibly consistent with natural fracturing patterns in cometary nuclei. That phrase, possibly consistent, is doing enormous heavy lifting. It's the kind of diplomatic language institutions use when the data is screaming one thing, but the implications are too profound to state directly. I've spent 40 years in physics. I know how scientific institutions respond when they encounter the genuinely inexplicable. First comes denial, dismissing anomalies as measurement errors. Then comes desperate attempts to fit observations into existing frameworks, no matter how implausible the contortions required. Only after exhausting every conventional explanation do we reluctantly acknowledge we're facing something genuinely new. We're currently stuck in stage 2 with 3i Atlas. Watching the scientific community twist itself into knots trying to explain deceleration through exotic outgassing mechanisms, geometric internal structures through natural fracturing, precisely stable rotation through improbable mass distribution. At some point, Occam's razor demands we accept the simpler explanation, even if it's psychologically uncomfortable. But there's another layer to this that we haven't adequately addressed. What is 3i Atlas actually doing right now? If it's an autonomous probe executing pre-programmed instructions, those instructions might include very specific objectives for planetary encounters. The internal reconfiguration we're detecting could represent deployment preparation, not necessarily landing craft or contact vessels, but observational equipment, sensors extending from the protective hull, communication arrays unfolding, perhaps even smaller sub-probes preparing for release. Avi Loeb's dandelion seed hypothesis suddenly becomes less metaphorical and more operational. If 3i Atlas releases smaller objects during its perihelion passage, when we can't observe it behind the sun's glare, those objects could disperse throughout our solar system before we even realize they've separated. Think about the strategic brilliance of that timing. Maximum solar proximity provides maximum energy for any power-hungry deployment operations. Earth's observational blind spot ensures the parent craft isn't being monitored during critical maneuvers. And by the time 3i Atlas emerges from behind the sun in December, any sub-probes could have already entered stable orbits around Earth, Mars, or Jupiter, appearing as tiny objects easily mistaken for asteroids in our crowded solar neighborhood. The Galileo Project observatories that Loeb directs have been placed on high alert. These facilities use multiple sensor types to detect and track anomalous objects in Earth's atmosphere and near-space environment. If new objects appear in our skies after October 29th, if tracking stations detect orbital insertions that can't be attributed to known satellites or natural bodies, the correlation will be impossible to ignore. But here's what keeps me awake at night, what I believe represents the most terrifying aspect of this entire situation. If 3i Atlas is indeed an ancient probe following million-year-old programming, what were its instructions? Different civilizations would design probes with different mission parameters based on their values, fears, and objectives. An optimistic civilization might build probes to identify other technological species and establish communication. A cautious civilization might design probes to observe silently, gathering data without revealing their presence or origins. But a fearful civilization, one that had experienced existential conflict with others, might create probes with very different instructions. There's a concept in game theory called the dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin. It suggests the universe operates like a dark forest, where every civilization is a hunter moving silently through the trees. Any civilization that reveals its location risks being eliminated by others who strike first out of self-preservation. In such a universe, the optimal strategy is silence, and if you detect others, elimination before they can threaten you. Now imagine von Neumann probes built under dark forest logic. They wouldn't seek communication. They'd assess whether detected civilizations represent potential threats to their long-dead creator's legacy. And if those civilizations show signs of developing interstellar capability, if they're broadcasting their presence loudly through electromagnetic emissions, if they're showing the technological trajectory that might lead to them exploring outward and potentially encountering whatever remnants of the probe civilization might still exist, well, the programming might call for preemptive action. I'm not saying 3i Atlas is a weapon. I'm saying we don't know what 3i Atlas is. And that uncertainty, combined with the increasingly undeniable evidence that it's artificial and actively reconfiguring itself, should concern us deeply. We have exactly 6 days until perihelion. 6 days until 3i Atlas reaches its closest solar approach and disappears behind the sun's glare. 6 days to gather every scrap of data we possibly can before our observation window closes. Every major telescope on Earth should be pointed at this object right now, not to confirm what we already suspect, that it's artificial, but to understand its intentions. The infrared reconfiguration patterns might contain structure, information, even communication attempts we're simply not recognizing yet. The geometric spacing of internal elements might encode data about its origin, its age, its purpose, and if December arrives and we observe new objects in our solar system that weren't present before, if tracking networks detect anomalous orbital insertions, if the Galileo Project sensors register activity that conventional explanations can't account for, we'll need to make a civilizational decision about how to respond. Do we attempt contact? Do we maintain observational silence? Do we prepare defensive measures against a threat we don't understand? These aren't questions for scientists alone. These are questions for all of humanity, because the answer will define our species' first real test on the cosmic stage. As a physicist, I've always believed the universe operates according to knowable laws, that everything can ultimately be explained through mathematics and observation. But I'm also humble enough to recognize when we're confronting something that challenges our frameworks. Atlas challenges everything. Whether it ultimately proves to be a ghost ship from a long-dead civilization, an active probe serving masters we'll never meet, or something entirely outside our current conceptual categories, it has already accomplished something profound. It's forced us to confront our cosmic solitude and our cosmic vulnerability simultaneously. We are not alone. But we might not like what that company represents. Subscribe now and follow this channel closely over the next week. October 29th will answer some questions, but I suspect it will raise far more. And whatever revelation emerges from behind the sun in December might be the most important event in human history. Because ultimately, whether 3i Atlas represents hope, threat, or simply indifferent machinery following ancient programming, it carries one undeniable message from the cosmos itself. The universe is stranger, older, and more filled with ghosts than we ever imagined.